Swayam Prabha. Digital India. Educated India.
Welcome back. So this is our last topic in natural hazard, one of the most important one, since most of us, mainly the people who were staying along the east coast and the west coast of Indian mainland were surprised, and even the people from Andaman were surprised and shocked to have 2004 tsunami. But I would say that this is not the first time such tsunami has occurred in this region. We have signatures that in past also, during recent historic past also, this region has experienced much larger tsunamis than what we experienced in 2004. That was, the source was from Banda Aceh, Indonesia, but even we can have similar large magnitude or maybe more damaging tsunami if it is triggered along the Andaman Islands, and we have evidence that in the past such tsunamis have occurred. Now, in most of the literature and on any website dealing with the institutions dealing with natural hazards and all that, you will find this picture, which is commonly confused or maybe is taken up as in that the artist who wanted to show sort of a huge or great offshore wave has been taken as in tsunami wave. So Hokusai never thought of that this picture or the sketch which he is preparing will be used or interpreted as a tsunami wave. But of course it's tried to show, he has tried to show that the giant or the great offshore waves are even much more greater than the Fujiyama, which has been shown here. Let's move ahead and see what best we can learn out of the experiences we had recently from Andaman, from Tohoku, Japan, and again from Indonesia. So as we discussed in the beginning, and some part we have already discussed in the other course about the plate tectonics. So everywhere you will not experience or expect the tsunami to occur, but there are typical zones which are the subduction zones mainly, where the oceanic plate is subducting below the continental plate, will have the greater chances to trigger tsunami. So one such zone which I am right now pointing out lies in the domain of Indian subcontinent. So we have like a chance of having the great tsunamis along this belt, as well as, which is not shown here, there is a Makaran subduction zone, which is also another vulnerable area or the area which can trigger large magnitude earthquakes as well as the tsunamis, but it will not be as large as what we have experienced here. So in short, like if the tsunami has been triggered along this location, it is not that only this location or the area adjoining this will be affected, but the region. So it will be sort of what we call is transoceanic tsunami. So we'll be talking about one of the example of 1960 tsunami of Chilean, which was triggered by one of the largest earthquake of magnitude 9.5, and which affected, that was in 1960, that affected the whole region in the Pacific area. So the point is that even if you are sitting away from the subduction zone, because this is the area which is tectonically active, and for example we are sitting on the east coast and the Sri Lankan part here, and the region on this side, of course, will be the area close to it will be affected, but even the area which is sitting away need to be alert from such hazard. So, if you come as a definition, this word tsunami, it came definitely from Japan, which means an harbor wave. So, this was which we have been using in our literature as well as our research. So, the height of the tsunami wave is small and barely noticeable in the deep sea. So, few important things here, but becomes larger and damaging when it approaches the coast. So, it will have a very large wavelength in the ocean, but it as approaches the coast, then this will become it will become like more damaging as it reaches the coast, and the height also goes up. So, it is barely noticeable in the ocean. So, if you are sailing on this region, then you will be able to just move very smoothly over the crust and the trough of the tsunami, which the wavelength can be of hundreds of kilometers. Okay. So, here it has been shown, like for example 200 kilometers of wavelength, but yes, of course, that as it reaches the coast, it will stack up one by one, and of course the height, it will result into the increase in height. So, the amplitude will increase as it reaches the coastal area, and it will be more damaging. So, if you look at this small cartoon, what does it explain is that you have an subducting plate, that is what you take as an oceanic plate, and then the overriding plate is your continental plate. So, this phenomena is not happening quickly, but it keeps going on for several years. So, what is like we have learned from the tectonic deformation, that there is an ongoing deformation which keeps going between the two plates here, and this will result into the deformation of the overriding plate. So, the land level change will occur over the time. It may be for 500 years or 600 years. For example, in the Andaman region and the Sumatra region, what recurrence we are getting is around 400 to 500 even years to have the similar magnitude tsunami or similar magnitude earthquake, which can create or trigger damaging tsunami. So, this plate which is riding on top of it, partly covered by the ocean water, will deform, and there will be a land level change. So, what best we have done now is that the scientists or the people who are working in this domain have kept or installed permanent GPS stations, which can help in understanding that what is the rate of deformation in this area, and based on that what is the amount of strain which is getting accumulated in this region, and when next earthquake can be triggered. Okay. So, if you look at this, kindly watch carefully what is happening here. You can easily make out. So, there is a locking which will of course result into the deformation of this one, and then what we see is that this island is sinking down, and when this was released, it resulted into an uplift. So, it has come back and the waves were been generated. So, this basically talks about that sudden release of the energy and the disturbance which has disturbed the water column, and which definitely will result into the generation of the waves, and those waves are your tsunami waves, and which will definitely affect the whole area in the adjoining region. So, again I am playing and you can watch it carefully. So, it is going down and then it will be released. So, this sudden release is your earthquake here. So, this earthquake has triggered the sudden displacement of the water column, which has created a tsunami wave. So, if you look at this is this example is from the Miyako, Japan, but the tsunami which was recorded here was from 1960 Chilean earthquake tsunami. So, this clearly suggests that there was no earthquake shaking or seismic shaking in Japan during this time, but the tsunami reached Miyako Island and which affected this area, and this was been recorded. So, this is a normal estimated tide curve, and the arrival time of the tsunami was marked by this. So, very high amplitude were been recorded. So, this was maximum amplitude, whereas this is the your estimated tidal curve. So, tide gauging stations can help us in identifying if there is sudden change in the arrival, or is there any disturbance in the tides. So, long water wave generated by sudden displacement underwater. So, what we saw in this the cartoon, it shows the displacement along the two plates or the fault which disturb the overlying water column. So, tsunamis also called as seismic sea waves, because they are related most deadly tsunamis are due to the seismic events, and are a series of waves generated by large violent earthquakes occurring near the ocean. Not all earthquakes generate tsunami. Now, this is again based on that what type of displacement will take place. Either the displacement is a reverse type, where the plate has moved up along the fault, or the displacement is sudden normal along the normal faulting, or the movement is along the, like for example, strike slip. So, reverse faulting, or you can say thrust faulting, and then normal faulting, and strike slip. Now, it was been believed until now, and still the groups are working on this, that mostly when we say the reverse faulting, then one block has moved up with respect to another one, and here one block has moved down with respect to another one. Whereas in this case, that is in strike slip, not much of the vertical displacement you will be able to observe. So, in these two cases, either reverse fault or thrust faulting and normal faulting, you will have vertical separation, whereas in strike slip motion or strike slip deformation, not much will be the component of vertical separation, but that has proved things wrong in terms of like if you consider the recent Palu tsunami of 2018, but nevertheless the displacement or the deformation triggered the landslide. I will talk about that in the next coming few slides, or maybe in the next lecture, about that what happened exactly during the Palu tsunami. So, mostly if we have this two type of movements, we expect that there will be a huge tsunami. Otherwise, if you are having this, then you may say that it may or may not be depending on the vertical separation. So, the vertical separation during an earthquake is extremely important, because that will result into the displacement of the water column. Now, if you differentiate between the normal sea waves and the tsunami waves, then there are major difference we can look at quickly. So, normal sea waves and tsunami waves, the wavelength range up to 1 mile or around 1.6 kilometers, whereas in the case of tsunami, it will be of hundreds of miles, as we are looking at one of the example. Okay, few miles an hour up to 60 miles an hour. This will be the speed which will be seen in case of the normal sea wave, but in in case of the tsunami sea wave, it can attain the speed as high as the plane, almost like 800 kilometers per hour or more. Generated with the gravitational attraction due to moon and sun, and these are generated with earthquakes. Nevertheless, along with this, we can expect an tsunami because of the volcanic eruption, then we have landslides, or if you are having meteoritic impact. So these are few more reasons for creating tsunami, because this phenomena or the process will also affect the water column or disturb the water column because of its sudden impact. So coming to this point here, not the first wave can be most powerful, and many people who are staying close to the coastlines, they never understand that whether the flooding, the local flooding which is taking place, is related to the tsunami or something else. Okay. And this same was experienced in 2004 tsunami by people who stayed in Car Nicobar. So they would never realize that this was the inundation which took place suddenly was due to the tsunami. But nevertheless, they experienced very strong ground shaking. So that was one indication that there could be a tsunami. And the duration also can be shorter for several minutes, or it can go up to tens of minutes. And in the areas where you are having the bay, which are narrow areas, one can expect the high tide levels of tsunamis. Hit as fast as aircraft or a bullet train. So these are few things which we should keep in mind, that we should not underestimate the sudden change in the tide level or maybe the water level close to the coast, and we should keep in mind that it will be quite powerful. Okay. So why tsunami is so destructive? The reason is that as the tsunami waves enter the shallow water near the coast, either it is bay area or what, its velocity decreases, but at the same time its height increases. So in the ocean you will have a very large wavelength. So the amplitude will be not as high as what we see here close to the coast, but it will be very shallow and it will be barely noticeable. But as it moves and climb up the coastal regions, it starts stacking up, and that can result into the increase in height as well as the runoff and the region. So crust height more than 30 to 50 meters and the strike with devastating force. This was noticed in one of the region in Indonesia in 2004. So if you see, it will be like an sea wall which is traveling towards the coast. Okay. And so I don't know what must have happened to these people. Of course, they might have swept away during this one. This is from the Rabi tsunami, Thailand area of 2004 tsunami. So the height or run up is another important factor which we should keep in mind. And usually what we do is, what the tsunami geologists, that they will go back into the field during or after the tsunami, and then try to measure all this heights and run ups and all that, which are important for modeling as well as for the future hazard assessment. So run up of the tsunami at point of impact will depend on how the energy is focused, from where the tsunami waves will be coming or it expected, and second is the travel path of the waves, okay, how they are traveling, what is the configuration of the coastal region, because this will again depend on the offshore topography. So if you are sitting on very high grounds, then you will not be affected, but if you are, for example, you are having in a very shallow bay areas, then you will have different wave height. So, the energy focused from where it has been triggered, for example, if you are having the Indian continent and then you are having the subduction zone sitting here, then if the tsunami is triggered from this region, then it will be focused, it will travel in this direction, in all direction here. But if it is over here, then it will be very straight reaching this place. Okay. So, the energy, how energy is focused and what will be the travel path, because travel path will also reduce the impact if you are having the longer travel path. If you are having shorter travel path, that will be. So, these are few things which are important. Then coming to the tsunami run up is the vertical distance between the maximum height reached the water onshore. Okay. So, onshore, that what we were looking in the next slide also will explain this. Onshore, how far it has reached, and the mean sea level surface. This is the mean sea level surface will be at the time when the tsunami was triggered, because we have the tidal charts with us. We can go back and try to see that and try to look at that what was exactly the run up with respect to the sea level, mean sea level at that point of time. So, if you consider this the method measuring the tsunami height, then what you have is finally the C is your tsunami height, where A, and it can be given as A plus B is equal to C, that is the tsunami height. A is the measured height. Now, the measured height is at the time of the tsunami. So, this is the measured height, and then B is your tidal difference between the measured height at tsunami and at the time of the measurements, because you will not be measuring at the time of when tsunami has occurred, but based on the height is marked. Okay, that is based on the this is the sea level at the time of the tsunami, this was, okay, and then this is your height of the at the time of your measurement. So, that will give you the inundation height or run up height. Okay. And one can also look at which can be easily one can find, that is, one is the watermark and also the wounded trees and the bent twigs. These are few things which we usually take in. If at all this house is survived, then we can see, and also because the tsunami waves will carry the debris, either it is plant debris or some other things which will be found very far off inland, that can be taken as an indication of the tsunami wave. So, picture from Indonesia again 2004. So, you can compare both the satellite data is from Google Earth and what exactly. So, this is the only 2-3 houses is cluster was left out, the rest was completely destroyed or wiped off. So, if you look at the run up how it looks like, so in this video you will be able to understand that if you are the first wave may not be very powerful and you may have the negative wave. So, in this video what it's been shown is that the first arrival of the first wave was negative, hence it went back. So, in some of the events or the tsunami and earthquake events, what people did was that when the sea receded because of the negative wave, they went into the sea, and that recede can be up to kilometers. Okay. So, in case of Andaman also, few people they observed this negative wave. So, what you are going to get, like if you are having this wave, okay, so either you are going to get this one or this one, you never know that. So, if you are having a negative wave, that will recede, because as commonly seen during the type of if you go to the beach or the close to the ocean, you will find the wave comes and goes back, wave comes and goes back. So, that will the wave recede will be your negative one, and that what happened in 2004 in some places. So, if you look at this one, the first wave of course was not so powerful, but the rest So, this is the receipt of the ocean exposing the area, and then the next wave inundated the area completely and again went back. So, this is this again will depend on the amplitude of the wave and of course the configuration of the coastal region. So, I will stop here and we will continue in the next lecture. Thank you so much.